The Cultiuana CT-800 is a foldable LED bar grow light with about 800 watts of power. It has an interesting reverse hinge design, and it's well made. The clear selling point for the CT-800 is the cost. The CEO of Cultiuana claims that the CT-800 is the best value for its performance. It's considerably less expensive than similar models from other brands, but value is about more than just price.
Hello growers, I'm Dr. MJ Coco from CocoForCannabis.com. There are a lot of companies like Cultiuana that appear to offer great deals, but it can be tough to tell if the quality and performance will stand up. Is it a great deal or simply a low price? I decided to test the Cultiuana CT-800, and I'll use this review to explore the importance of performance and cost in the determination of grow light value.
I run the Cultiuana CT-800 through 6 PAR and ePAR tests. I run the official tests in a 5x5 test area, and then I run it in a 4x4 space with ppfd levels set for growers with supplemental carbon dioxide and without.
To better understand value, I'll compare the CT-800 to two of the most popular lights in this class, the Mars Hydro FC-E8000 and the Spider Farmer SE7000. There are big differences in performance and cost, but there's no clear winner. All growers may never agree which light offers the best value, but I think all growers can agree that we all benefit when we better understand the trade-offs.
There's no doubt that the Cultiuana CT-800 has a great price, and we have a 10% discount code for Cultiuana.com. Use code CCFC. With the discount, your cost for the CT-800 is only $459, and that includes free shipping. Comparable lights that I've tested cost at least $150 more. But to understand grow light value, we need to go beyond just the purchase price. In addition to the cost, we also need to consider how much light we get. The usable ppf is the amount of light that reaches the canopy and which you can use to grow plants. Fundamentally, when buying a grow light, we are buying usable ppf. So to begin estimating value, we need to consider both cost and light. We can take the cost in dollars and divide it by the usable ppf in micromoles. That is cost efficiency. We measure it as the cost per micromole of usable light. It's a critical component of value, and I expect the CT-800 will do very well. However, cost efficiency does not consider how much power a fixture uses. The amount of power a fixture uses determines how expensive it is to run and how much heat it will add to your grow space. So we need to consider the amount of light that we get and the amount of power that it took to get it. The usable ppf in micromoles divided by the power in joules or watts. That is photon efficacy, PPE. We measure it as micromoles per joule or watt. Certainly there are other dimensions to consider, but to understand value, we need to at least consider both cost efficiency and photon efficacy. Of course, most fixtures that excel in one of these metrics do not excel in the other. Your budget often determines which metric defines value for you.
One grower doesn't have to worry about budget. If you're watching during the live premiere on YouTube, you could win the Cultiuana CT-800 that I tested for free. Just guess a 3-digit number in the live chat and stay till the end of the video. If you missed the premiere, be sure to subscribe to my channel so you don't miss the next one.
The Cultiuana CT-800 arrives in this large but thin box. Be aware, it does not hide that it's an LED grow light. I'll get the box out of the way and see what's inside. It's mostly just the folded fixture and this accessories box. Oh, and a 1-page instruction sheet here. Let's open this box. Okay, they give us a plug adapter if we want to plug into 220 volt. This is a simple hanging kit. I need to pull the power cord out, and a little daisy chain RJ cable came with it. I'll slip the packaging off and we'll take a closer look. Here's the power cord, RJ cable, hanging hooks in with the plug adapter, the hanging kit, and instruction sheet. In the center chassis here, there are two 400-watt drivers manufactured by Novbo. As we look at the light itself, you notice that the fixture is folded and the diodes are facing out. I'll discuss the pros and cons of this design. To start, it seems a little dangerous, but it makes it easy now to zoom in and see the diodes. They're arranged in rows of 4 along each bar. The full spectrum diodes appear yellow, and they're interspersed with 660 nanometer and 730 nanometer diodes, which appear white or clear. The diodes are evenly distributed from end to end along the bars. Let me get it set up for the tests. The hinge design on the CT-800 allows the fixture to lay very flat for shipping, and the reverse hinge means the diodes are already facing down when it's unfolded. That part is easy. They provide these hanging hooks which you attach to the central chassis. They're a little tricky because they're bent both ways. They provide a wire hanging kit, but I'll use my own ratchet pulleys. One of the drawbacks to this design is that the only place to hang the fixture is the central chassis. If we pulled up on the corners, it would just start folding up. So there are only 2 points of connection, and it may be tough to get the fixture hanging level. I'll return to that later. Now I just need to get the CT-800 plugged in and turned on. The Cultiuana CT-800 uses eBright and Sanan diodes. There are 2,400 full-spectrum diodes at 3800K and 384 red 660 nanometer diodes. The CT-800 also features 96 far red 730 nanometer diodes. That's a total of 2,880 diodes. It's about 3.6 diodes per watt, or 0.28 watts per diode. Although the diodes are not from the more popular brands, at that current, they should have good efficacy and longevity. All diodes are most efficient when they're cold, so I need to let them warm up and stabilize before running the tests. Let's check out the published stats. This is the CT-800 product page on Cultiuana.com. You can see the current price here is only $510, and we have a 10% discount code. Use code CCFC. Your cost will be only $459, and that includes free shipping. I'll scroll down so we can check the important specifications. The power draw is listed at 800 watts, and the efficacy is listed at 2.8 micromoles per joule. That's a calculated ppf of 2,240 micromoles. Let's take these data and run them through the Coco for Cannabis grow light calculator. This is our tool to help growers evaluate and compare grow lights. It focuses on the important metrics and allows growers to compare different lights. In the calculator on the right, I load all the fixtures that I test. If the fixture you're looking for is not there, you can enter data from manufacturers in the calculator on the left to estimate performance. The CT-800 is listed at 800 watts. If you use discount code CCFC on Cultiuana.com, your cost will be $459. The ppf data that we got appears to be a calculated value. They list 2.8 micromoles per watt, or 2,240 micromoles. The calculator predicts that 1,642 micromoles will actually reach the canopy. That would be a usable PPE of 2.05 micromoles per watt. This photon efficacy is not remarkable, but 28 cents per micromole is. That would be a new cost efficiency record if it stands up. According to the calculator's estimates, the CT-800 will be able to cover a 5x5 space. You can expect to harvest 44 ounces. It's time to run the tests and see how accurate the calculator is. I have the CT-800 set up in a 5x5 test area. In order to get it to hang level, I had to add a brass weight. The rep at Cultiuana said they will send yo-yo hangers to help you balance it if you have trouble. I use an Apogee SQ500 sensor to set the hanging height and run the PAR test. PAR is light from 400 to 700 nanometers. Traditionally, it was considered the only light that powered photosynthesis. In the last several years, research with advanced LEDs and lasers demonstrated that far red light from 700 to 750 nanometers is also photosynthetically active. The new metric ePAR, extended PAR, adds far red to the traditional PAR range. ePAR is 400 to 750 nanometers. I use an Apogee SQ610 sensor to measure ePAR. All full-spectrum LED grow lights generate some far-red light. Full-spectrum diodes use a 450 nanometer semiconductor and phosphor to filter that blue light to longer wavelengths. About 3 to 4% of the light ends up in the far-red range. The CT-800 also uses dedicated far-red diodes. They contribute to the ePAR results, but are not measured in the PAR test. An ePAR map is the best representation of the growth potential of a grow light. But let's look at the PAR map first. This is a pretty standard distribution of light. For my official test, I adjust the hanging height so that the maximum ppfd is exactly 1000 micromoles per square meter. And there's a fairly large area near the center above 900 micromoles per square meter. Moving away from the center, ppfd drops. For growers with ambient levels of carbon dioxide, I recommend staying below 1000 micromoles per square meter, but I also recommend staying above 500 micromoles per square meter. The CT-800 keeps most of the map above that threshold, but the density of light drops into the mid 400s in the corners. 5x5 areas are tough to cover, and this is not a bad result. I'll flip to the ePAR map. As I explained, ePAR is PAR plus far red. Since ePAR includes a wider range of light, the density is always higher in the ePAR map. Since the CT-800 uses far red diodes, the numbers went up more than usual. To see how much far red light there is, we have to run the numbers. The hanging height for these tests was 47 centimeters, or about 18.5 inches above the sensors. That was the hanging height where the maximum ppfd was 1000 micromoles per square meter. In the PAR test, I measured an average ppfd of 703.9, which is great. In a 5x5 test, that converts to a usable ppf of 1583.7 micromoles. In the ePAR range, the maximum density is 1059 micromoles per square meter, and the average density is 751.4 micromoles per square meter. It's a usable ePPF of 1690.7 micromoles. The usable ePPF is 107 micromoles more than the usable ppf. That means the CT-800 delivered 107 micromoles of far red light. That's about 6.3% of the total flux. That's suitable for veg and flower. I measured the power draw from the CT-800 at 762 watts. So, it delivered 2.08 micromoles per watt in the PAR range and 2.22 micromoles per watt in the ePAR range. Just a couple of years ago, I would have considered that excellent. It's better than almost any quantum board or cob. It's way better than HPS. However, LED bar fixtures have pushed to higher efficacies. The most popular models are now getting about 2.3 to 2.5 micromoles per watt in my official 5x5 ePAR tests. Let me compare this ePAR test with the CT-800 with one of the most popular lights on the market, the Mars Hydro FC-E8000. FC-E8000 generated an excellent map, with values above 600 in the corners. The maximum ePPFD was lower than the CT-800 because the FCE8000 does not have 730 nanometer far red diodes. But the average ePPFD is considerably higher, which means the usable ePPF is also higher. Now, it is true that the FCE8000 draws a little more power, but the bigger factor is that the FCE8000 has a better photon efficacy. What may make this a tough call is that the FCE8000 also has a higher price. If you use discount code CCFC on marshydro.com, you'll pay about $611. With 1,829.7 micromoles, that's only 33 cents per micromole. But it's still over $150 more than the CT-800. Use code CCFC on Cultiuana.com and you can pick up a CT-800 for only $459. That is a new record-setting cost efficiency, 27 cents per micromole. Now, both of these lights can grow a great 5x5 garden. I cannot tell you which is a better deal for you. I can only point out the trade-offs. And I got more tests to run. The CT-800 puts out enough light for a 5x5 tent, but it will also fit in a 4x4 tent. As the price of LEDs has come down, more and more growers are buying them for 4x4 tents. In this space, there are only 16 square feet for the light to spread into. Therefore, the density of light will be higher. At full power, the CT-800 puts out more light than I can recommend for growers in ventilated spaces. So these tests are for growers with elevated levels of carbon dioxide in a sealed space. I ran a PAR test and an ePAR test with the CT-800 30.5 centimeters or 12 inches above the sensors. In ventilated grow spaces, the ambient level of carbon dioxide is about 400 ppm. I recommend a maximum ppfd of 1000 micromoles per square meter. In a sealed space with supplemental carbon dioxide, you can run more light. With CO2 levels at 1200 to 1500 parts per million, you can run a ppfd up to 1500 micromoles per square meter. It may seem like a hack to get more growth, but it's not very efficient. To actually raise the level of carbon dioxide to the required level, you need to seal the space. It means no more exhaust fan. So you have to run AC and dehumidification or reheat to control the climate. Unless you already have to do all that, running supplemental CO2 is expensive. But if you do have to do all that, you might as well crank up the light. Let's check out these maps. Core map is up first. The distribution here in the 4x4 space is much better than the distribution in the 5x5 space. That's always the case. In the 4x4 space, the CT-800 is almost wall to wall. So even at a low height, plenty of light reaches the corners. The values are somewhat higher in the ePAR map. The distribution from top to bottom is excellent. Out along the sides, there is somewhat less light. Those are the edges along the ends of the LED bars. But even though the ppfd drops off, it's still above 900 micromoles per square meter, almost everywhere. Let me run the numbers on these CO2 tests. I set the hanging height for these tests at 30.5 centimeters, or 12 inches above the sensors. In the PAR test, the maximum ppfd is 1,327 micromoles per square meter, and the average ppfd is 1,093.5 micromoles per square meter. In a 4x4 test, that's good for a usable ppf of 1,574.6 micromoles. In the ePAR test, the maximum density is 1,408 micromoles per square meter, and the average density is 1,172.1 micromoles per square meter. That converts to a usable ePPF of 1,687.8 micromoles. I measured a power draw of 762 watts during the tests. So the CT-800 delivered 2.07 micromoles per watt in the PAR range and 2.21 micromoles per watt in the ePAR range. Again, the efficacy numbers are somewhat lower than the most popular models. I don't think most growers will run the CT-800 in a 4x4 space at full power. For most growers, this is too much light. So I dimmed the CT-800 to 80%, and I raised it up to 46 centimeters, or 18 inches above the sensors. At this height and power, the maximum ppfd is exactly 1,000 micromoles per square meter. As we discussed, this is the density limit that I recommend to growers who run at ambient levels of carbon dioxide. I ran a PAR test and an ePAR test in this setup. I suspect that this will be a popular way to set up and run the CT-800. With a tight fit, plenty of power, and a good hanging height, the light density is excellent. Large LED bar fixtures always crush this test. Some use less power, but the CT-800 is much less expensive. Let's check out these maps. I told you the light density was excellent. Here in the PAR test, the maximum ppfd is 1,000 micromoles per square meter, and this large area is all above 900 micromoles per square meter. The entire map is in the maximum production zone. Let me flip to the ePAR map. This is great. The lowest ePPFD is above 800 micromoles per square meter. If you want a uniform crop and an excellent harvest, this is what you're looking for in an ePAR map. Growers in 4x4 tents are going to be tempted with this. $459 to get this map. But there's more to consider. Let's run the numbers. I dimmed the Cultiuana CT-800 to 80% for these tests. I raised it to 46 centimeters, or 18 inches, where the maximum ppfd is 1,000 micromoles per square meter. The average ppfd is 881 micromoles per square meter, and that converts to a usable ppf of 1,268.7 micromoles. In the ePAR test, the maximum density is 1,073 micromoles per square meter, The average density is 946.3 micromoles per square meter. That's a usable ppf of 1,362.7 micromoles. It is as much light as I recommend running with ambient CO2. Power draw at 80% is 624 watts. So the CT-800 delivered 2.03 micromoles of PAR light and 2.18 micromoles of ePAR light per watt. Like I said, all large LED bar lights can create great maps in this test, but the photon efficacy determines how much power they will need to do it. Let me compare this ePAR test with the CT-800 with another of the most popular lights on the market, the Spider Farmer SE7000. The SE7000 and CT-800 were hung at almost exactly the same height, and both fixtures were dimmed to 80% for the test. The SE7000 does not have far-red diodes, so it has a lower maximum ePPFD in the test, but the average ePPFD and the usable ePPF are higher with the SE7000. Both of these maps are great. You really do not need more light than the CT-800 is delivering. The biggest difference in terms of performance is the amount of power. The SE7000 has an excellent photon efficacy of 2.45 micromoles per watt, so it only needs 584 watts to generate all of that light. The CT-800, with only 2.18 micromoles per watt, requires 624 watts. That's 40 more watts, which creates 135 additional BTU per hour. So while both maps are great, there is value to having better photon efficacy. But what price are you willing to pay for that value? Use code CCFC on spiderfarmer.com and you'll pay about $672 for the SE7000. In this test, it put out 1,432.4 micromoles, so that's a cost efficiency of 47 cents per micromole. And again, with code CCFC on Cultiuana.com, the CT-800 is only $459. With 1,362.7 micromoles of usable light in this test, you're paying only 34 cents per micromole. The CT-800 will cost a little more to run, and it will generate a little more heat, but it costs over $200 less to buy. The realities of your budget will determine which is the best decision for you. You can find all of the maps and test data for the fixtures that I test on their test report page in the Coco for Cannabis Grow Light Guide. Here are the main data from the official ePAR test in the 5x5 area with the CT-800. It puts out enough light to cover 26 square feet, and we predict that you can harvest about 45 ounces. That's almost 3 pounds. Here you can find our discount code and the shopping link. Stop Cultiuana.com and get an extra 10% off with code CCFC. Currently, your price will be only $459. That comes to only 27 cents per micromole. That is the best cost efficiency that I've measured on any light. The price is the biggest selling point, but I didn't want to be too obvious with the winning number in the PAR Test Premier giveaway, so I did the price of 2, $9.18. If you guess the price of 2, you get 1 for free. Congratulations to whoever guessed the closest number. And if you missed the premiere, hit that subscribe button and get notified about the next one. Below the test data and the grow space calculator, you'll find my written review.
Testing the CT-800 has got me thinking a lot about grow light value. There really are a number of dimensions to consider, and in the end, different growers will make different decisions. The CT-800 can light up a 4x4 or 5x5 tent and grow great plants. It has plenty of power and can generate a great distribution of light. It comes at an incredible price. However, it is somewhat less efficient than other options. In a lot of cases, that'll just mean you end up running more power. But more power means more heat. Let's talk temperatures.
The room where I test is climate controlled at 25.5 degrees Celsius, 78 Fahrenheit. I measured the surface temperatures on the CT-800 after it had been running for several hours at full power. The LED bars had a high temperature of only 48.3 degrees Celsius, 118.9 Fahrenheit. The central chassis, which houses the drivers, hit a high temperature of 40.4 degrees Celsius, 104.7 Fahrenheit. However, surface temperatures do not correspond to the heat added to the space. When we think about how hot a fixture makes the space, we're thinking about BTU per hour. And the BTU impact of any appliance is a function of its power draw. There's a simple formula to estimate it. Multiply the power in watts by 3.41 and you get the BTU per hour. At full power, the CT-800 will add about 2,600 BTU per hour. To dial in the power, the Cultiuana CT-800 has an onboard dimming knob. It has preset options for 40, 60, 80, and 100%. I tested the dimmer in the 5x5 area at the official test height, 47 centimeters, 18.5 inches. As you can see in the chart, the dimmer ran a bit stronger than expected, but it is close. The preset positions may limit some growers. If you want to get more control over the dimming, you can use an external 0 to 10 volt controller.
The CT-800 has what home growers need in a light. I think the build quality and components are fine. It has plenty of power and creates great maps. Growers often worry whether companies like Cultiuana will honor warranties or even have any customer service. I understand the concerns, and I will not review lights until I can be confident that I can guarantee customer service. As with all the companies that I review, if you buy a Cultiuana light using our code and later have trouble resolving customer service or warranty issues, I will intervene on your behalf. If you're on a tight budget, the Cultiuana CT-800 can get you growing with a ton of light at the best cost per micromole that you can find. But it will run more power than some other fixtures to get the same amount of light. The more power that you use, the more your grow will cost in the long term, and perhaps more importantly to many growers, the more power that you use, the more heat you generate and have to manage. There are always trade-offs. I hope this exploration of grow light value and the CT-800 will help you determine the best way to manage the trade-offs for your budget and your grow. What is the best value just isn't always the same for all growers. At Coco for Cannabis, we always put the grower's interests first. Our goal is to provide impartial, science-based testing and reviews for home growers. You support our work when you use our discount codes to purchase grow lights. If you have questions or want to chat with me, I do the Ask Dr. Coco show every Monday night for my Patreon subscribers. Check me out on Patreon, Dr. MJ Coco.
I'd like to thank Shirley at Cultiuana for sending me the CT-800 to test. And thank you for watching. Please give this video a thumbs up and subscribe to my channel. Turn on your notifications so you don't miss the next PAR Test Premiere giveaway.
And if you want to win a light, we're always doing grow light giveaways on the deals and discounts page at cocoforcannabis.com. Check it out. And while you're there, you can read our articles, chat with the community in the chat room, join our next grow challenge, and try your hand at the grow light calculator. Grow your own, but don't grow alone. Let's grow together. I'm Dr. MJ Coco, sending all of you grower love.